Hi darling, so here we're going to do one of the most important things in chemistry, is to name compounds. In particular, today we're going to name binary ionic compounds. So you're going to know what ionic compounds are. You need to know the predictable charges. We're going to talk about how to name each of them. Now there's two different ways of naming them. For binary ionic, that's metals that form one ion and metals that form more than one ion. You'll also need your periodic table, so go ahead and grab that right now. So ionic compounds are any cations and anions. Now remember, cations form positive charges, anions are negative charges. In ionic compounds, electrons are transferred from one atom to the other. So when we have, for example, sodium and chlorine together, we have Na and Cl. Well, if we take a look, Na is group 1. It actually has one valence electron. I'm going to show that Lewis dot diagram like I did before. I'm going to show that one electron. Chlorine is group 17 and actually has 7 valence electrons. So what ends up happening is that this last electron from sodium gets transferred over to chlorine. So sodium then has a positive charge and chlorine has a negative charge. So that's an ionic compound, and that's how electrons are transferred. So first we need to talk about the predictable charges from the periodic table. You do know that on the top right, those are the charges, those are the oxidation numbers. But if you didn't have like the New York State table, or if I just ask you about the table up on the large table up on the wall, you know that group 1 is plus 1, group 2 is plus 2, and then going over to group 13, that's plus 3, group 14 is plus or minus 4, group 15 is minus 3, and so it kind of goes backwards there. We have group 16 that's negative 2, group 17 is negative 1, and then group 18 is 0 because they don't lose any electrons or gain electrons. So any of those positive ones, they can lose that many electrons. Any of the negative ones, they can gain that many electrons. We also have, I just want to kind of go back. Don't forget that those transition metals are, let's see, sorry kiddos. Those transition metals right there in the middle, as well as some of these guys over here, they can have ions with more than one charge. So for example, we have Sn, tin, that can be plus 2 or plus 4. Bismuth can be plus 2 or plus, I can't read it on the screen. Actually, I don't know what that is there. Pb can be plus 2 or plus 4. We have cobalt, plus 2, plus 3, and copper, plus 1, plus 2. So all of these guys can have more than one charge. Definitely take a look at the top right corner, especially for those positive ions, those cations or the metals. All the same thing here. So to write binary ionic formulas, we have 4 steps. 1, we need to assign the charges, and that's what we need to know the charges from the periodic table for. Then 2, we crisscross the charges. I'll show you how to do that. 3, we can reduce any of the subscripts. And then 4, we actually can have rename the metal as is, and non-metal we can change to IDE. So these are how to write binary ionic formulas for anything that for any metal that only has one charge to it. So if you're taking any of these metals, like any of these guys, the group 1, group 2, the group 1, group 2, those only have one charges. Aluminum, for example, it's only one charge there. So some of these guys, again, only form one charge in there. Zinc is also going to be one of them in the transition metals. Let's do some examples here. We have sodium and chlorine. So sodium, we know its symbol is Na. It's a group 1, so it's plus 1. Chlorine. Now, for any of these nonmetals, just do the predictable charges. So chlorine is group 17. It's a negative 1. I'm going to crisscross the charges. When I say crisscross, that means I'm going to move just the numbers of those oxidation numbers down. All right, so the 1 of the sodium gets transferred and the 1 of the chlorine gets transferred. Do not crisscross the positive or the negatives. So you just want the number, not any of the signs. So here now we have Na, Na1Cl1. Now if you have any 1s, you don't need those 1s because they're implied, so you now have NaCl. So this is the compound that we have. And to name this, we're going to just name the metal as is, so it's just sodium. And then that chlorine changes to chloride. So sodium chloride. There we go. So that's sodium chloride. Next we have magnesium and oxygen. Magnesium's a plus 2, oxygen's a negative 2. So we are just going to crisscross those numbers down there, like this. So then we have Mg 2O2, and we can reduce this down so it can just be MgO. So that's the compound. The metal name always stays the same, so it's magnesium. But the anion, the nonmetal, we change that to IDE, so it's magnesium oxide. Alright, then we have aluminum and sulfur. So we have Al, it's a group 13, so it's plus 3. Sulfur will be negative 2. Again, those are your predictable charges. I'm going to move just the numbers down. So now I have Al2, excuse me, Al2, S3. I can't reduce that down any further, so it's just Al2, S3. And then that ends up being aluminum, because again we keep that metal the same, and the S is sulfide. So now we have aluminum sulfide. So sometimes they want you to know what they are, like knowing what the name of the compound actually is. So here, for example, we have aluminum and we have oxygen. So aluminum, we know is Al plus 3. Oxygen is negative 2. When we crisscrossed them, so we just want to show that, yes, when we crisscross them, we still end up with that same formula. And you'll see why later on when we have more than one charge. So it's Al2O3. Good. So, like we did before, aluminum. And we change the oxygen to oxide. So this is aluminum oxide. You always need to do this double check just to make sure. Then we have sodium. That's the Na plus 1. The sulfur is negative 2. So let's crisscross those charges just to make sure that they are good to go. So we have sodium, which is Na2. The S is a plus, or excuse me, will just be 1S. So yep, that checks out. So now we have sodium sulfide. Alright, then we have ZnCl2. So Zn is a plus 2. It's one of those transition metals that only have one oxidation number. So let's transfer down the numbers, and so I've got to put the number there, but it's still good to go. So Zn, let's do this, Zn 1 and Cl2. I don't need to put the 1 there because that's implied. So then I have zinc chloride. Good. Alright, so again, these are all when the metals only have one possible oxidation numbers. Sometimes we have metals with more than one oxidation numbers, like all those transition metals and the bottom parts of groups 13, 14, and 15. So here we have to assign all the charges, crisscross them, reduce, and name them. So those are pretty much the same steps, except the naming. This is the only part that's different than if we had oxidation numbers with only one charge. So we have Roman numerals. We have to know which version of that metal we are going to be using. And so just to remind you, these are Roman numerals. Make sure that you know these as well. And normally I put little lines like that on them. So those Roman numerals go in parentheses. The nonmetal, again, same thing, we change to IDE endings. So let's take another look. These transition metals, most of these guys have more than one possible charge. So let's see. So like a bunch of these guys in here have more than one charge. If they do, then you have to make sure that we go ahead and figure out, or do the possible crisscrossing for all of those charges. And don't forget, some of the other groups also have metals with more than one charge. Now do remember, like for example, nitrogen. That's a nonmetal. That has a ton of different charges there. But it's a nonmetal. I don't want to worry about the charges of the nonmetals right now. Just worry about the charges of the metals, or the different charges. So here we have tin, the Roman numeral 4, plus oxygen. So that Roman numeral is telling us that that tin is going to be a plus 4 charge. So again, it's really super helpful because it already tells you what the charge is. You don't need to look it up. Oxygen's going to be a negative 2. So when we crisscross the charges, that 4 comes down here, the 2 comes down there, and then you have SN2O4. It's 2 to 4, so we can actually reduce this down to SNO2. Alright, so that's the formula. Let's go ahead and name these. Now again, you need to make sure that you write the Roman numeral in parentheses. So tin 4, then oxide. Also, make note that the name of the metal and the Roman numeral, there's no space in between, like there is right there. It's just all clumped in together, and make sure that you write them out properly. So copper, Cu plus 2, fluorine is -1, and let's see, we can transfer those the numbers down. So it's Cu1, F2, or just CuF2. And then let's go ahead and write this. So it's copper, Roman numeral 2, because it tells you exactly what the charge is, fluoride. So I want to give you guys some kind of words of wisdom, some things that some other students have done incorrectly. One thing that they've done incorrectly is that they've assumed that the 1 in Roman numeral is actually which number down it is from the periodic table. Remember, this is New York State's table. It's not the one that everyone in the world uses. So always remember that Roman numeral tells you exactly what the charge is. It doesn't tell you, like, for example, it was like manganese plus 2, or yeah, manganese 2, Roman numeral 2. Many students in the past have thought, okay, so it's the second one down, so it should be 3. No, if it's manganese 2, that means it's manganese plus 2. All right? So again, just to make sure that you guys are aware of that, the Roman numeral tells you exactly what that charge is. Also, keep in mind that these are not all the charges that these transition metals can have. There can be more charges. This is just the common ones that New York State uses. So let's go to these examples. We have Fe and Cl2. So Fe is iron, and then Cl is chloride. We don't know which one, actually, we can go, sorry kiddos, let me just show you pretty much what we do if we're given the compound, but we're not given the name. So Fe, we're going to write down each of the possible charges that Fe has. Let's go back and find them. So Fe can be a +2 charge or a +3 charge. So we're going to write both of them out. So Fe +2 and Fe +3. Chlorine is our nonmetal. It's a group 17. It can only just be -1 for now. And we'll go ahead and crisscross those charges so that 2 comes down there, the 1 there. And I'll do the same thing here while I'm at it. So let's see. We'll have FeCl2 or FeCl3. We have to figure out which one of these two matches up with our original question. And that would be this one right here. So we're going to ignore this one, the FeCl3 right now. So we're just going to do FeCl2. So this would be iron, oopsies, iron, Roman numeral 2, and then a space, chloride. So the name of this compound is iron 2 chloride. Let's go ahead and take a look at copper. So you have Cu plus 1 and Cu plus 2 according to the table. Oxygen is always going to be a -2. So you have to write each one of them out. So this one would be Cu2O, and then the other one would be Cu2O2, but that reduces down to CuO. So we have to figure out which one matches the original problem, and that would be this one. So we'll write out, I'll write it up here so I have more space. Copper. I used the +2 version, so I'm going to write copper 2 chloride. Oh, just kidding, oxide. Alright, so it's copper 2 oxide. Then we have SnO2. So Sn is tin. It can be Sn plus 2 or Sn plus 4. So we have to write both of them down. Oxygen is going to be -2. We'll crisscross them. So when we crisscross it, this one ends up being Sn2O2, but that reduces down to SnO. This one ends up being Sn2O4, but that reduces down to SnO2. So this one is the one that matches up with our original problem. So we'll go ahead and write tin, Roman numeral 4. Ooh, that was awful. There we go. Okay, tin 2 oxide. No, excuse me, tin 4. Ooh, just kidding, kiddos. Tin 4 oxide, because again, that 4 is representing which oxidation number it was. Alright, so to summarize, if the metal only has one possible charge or one ion, so those group 1, 2, some of the group 13, and some of the transition metals, then it's just the metal and the nonmetal. The nonmetal changes to IDE. If the metal has more than one possible ion, so a lot of those transition metals, and then the bottom of groups 13, 14, and 15, then the metal has to be in Roman numerals with parentheses and use IDE. If they give you just the formula, then make sure that you do all the possible charges, list them all with whatever nonmetal that you have, check them all, just to make sure, reduce down if necessary. Alright kiddos, we'll have fun practicing this. Have a great day.